This is lesson 8.5, which is completing the square. I'll reveal the notes as we go. And so completing the square is a process. And before we go through that, I just want to talk about these two situations. So whenever you take the square root of a number, the square root of a number is positive. So the square root of 64 is 8. However, if we're doing something like this, which, by the way, we subtract 64 on both sides, it'd be x squared minus 64, which is a difference of squares, right? X plus 8, x minus 8, which means that this has two answers. And so if we're taking the square root as an inverse operation in order to undo the square, we have to add a plus or minus to the outside of that square root. Because the inverse operation of x squared is the square root, but we need to account for the fact that there's actually going to be two solutions to the original problem. So x will equal plus or minus, and the square root is always positive still. So the square root of 64 is 8. So quick notes, when taking a square root as an inverse operation, you must add a plus or minus sign to the square root. Okay, so why does this matter? Well, this is the same type of problem as this. So we can, because this is a perfect square, we can take the square root in order to solve this problem. Right now, instead of subtracting 64 on both sides and actually multiplying this out, setting it equal to 0, there's a different way of solving quadratics. And that's by using a process called completing the square. We're doing this tomorrow, but today we're learning how to set this up like that. Okay? So what is completing the square? Completing the square is a process that adds a value to make something a perfect square. So a perfect square is something like x plus 6 squared, or x plus 6 times the quantity x plus 6. This is a perfect square. So looking at this example, I want to add a value, x squared plus 12x, to both sides. I have to add it to both sides because it needs to balance it, so that this becomes a perfect square, right? So if we think about it, we want some value here so that this becomes the same number. This number would be 6 because 6 plus 6 is 12. And so then this number will be 6 times 6, which is 36. So we're going to add 36 to both sides. 13 plus 36 is 49. I'm going to rewrite that as a perfect square. X plus 6 squared equals 49. Now, some of you might be looking at this and saying, how on earth did she figure out that that's a 36? And I totally understand. So you can go here first to try and work backwards, or there is kind of a trick. How do we know the value to add? We're going to take this middle term, which is b. We're going to divide it by 2, so 12 divided by 2 is 6. And then you square it. 6 squared is 36. That's how we can get this number. B divided by 2 squared. So 12 divided by 2 squared. 12 divided by 2 was 6. 6 squared was 36. So let's go ahead and do these two examples together. First thing I'm going to do is I'm going to write out what I call the skeleton, because I need to add a value to both sides so that this is a perfect square. Again, something squared. So I'm going to take that middle term, which is b, divide it by 2, and square it. This will become x squared plus 8x plus 8 divided by 2 is 4. 4 squared is 16. I'm going to rewrite this as a perfect square. You're welcome to take 2 steps. 4 plus 4 would be 8. 4 times 4 would be 16. X plus 4 squared equals 25. That's the goal of today. So number 2, first thing I'm going to do, I'm going to write out the skeleton, because I need to complete the square so that this is a perfect square. The value that I'm going to add to both sides is b divided by 2 squared. I'm going to go to the side and do scratch work for this one. B divided by 2, that's negative 8. Negative 8 squared, that's negative 8 times negative 8, which is a positive 64. Negative 15 plus 64. I'll come to the side, do some scratch work here. 64 minus 15 is 49. I'm going to rewrite this as a perfect square. Now, if you notice, this number is always half of that number. So this number is going to be half of negative 16, which is negative 8. Moving on to the next part. For problems like this, okay, I'll even zoom in. Sorry, let me zoom in really quick. What we need to do is we need to set this problem up so the x values, or the x terms, are isolated. So unlike zero product property, where we'd add 3 to both sides so that it's set equal to 0, we actually want to first move the constant so that the x terms are over here by themselves. So my first move is actually going to be to add 75 to both sides. Leaves me with x squared plus 14x equals 75 minus 3 is 72. Now that the x terms are isolated, I can complete the square. So I add some value to both sides so that this is a perfect square. I'm going to add b divided by 2 squared. So this becomes x squared plus 14x plus 14 divided by 2 is 7. 7 squared is 49. 72 plus 49 is 121. This x squared plus 14x plus 49 is a perfect square, and that's x plus 7 times x plus 7. Next, what we need to do is we need to check the value of a. If you notice in all these problems, we've dealt with problems where a equals 1. We need to still do that. A has to equal 1. So the way that we'll change this, because this is 10, is we're going to divide every single term by a. That way, this becomes x squared plus 2x equals 8. Now that a is 1, I'm going to complete the square by adding b over 2 squared to both sides, so that this, is a perfect square. Sorry, don't want that yet. Okay. This simplifies to x squared plus 2x plus 2 divided by 2 is 1. 1 squared is 1. Again, the purpose of this is so that this is a perfect square, and that'd be x plus 1. Because x plus 1 times x plus 1 would equal x squared plus 2x plus 1. So now, wrong way. We're going to put this all together. Okay. All the steps into one problem. So we have 3x squared minus 12x plus 8 equals 1. If we want to set this up so that we can solve for x by completing the square, the first thing that you're always going to do is you're going to move the constants to the right. So here I have a positive 8, so I'm going to subtract 8. so that this is 3x squared minus 12x equals negative 9. And the purpose of this is so that the x's are isolated. That was the purpose of that move. So now we need to divide every term by a so that a equals 1. So we'll divide every term by 3 and reduce. X squared minus 4x equals a negative 3. All of this was just the setup so that we can complete the square. We're going to write the skeleton to complete the square. And the completing the square part, just so you know, is figuring out what value to add to both sides. So we need to determine the value to add to both sides by simplifying, or by doing b divided by 2 squared. I'll rewrite this one more time. B divided by 2 squared. Which is x squared minus 4x, negative 2, negative 4 divided by 2 is negative 2, negative 2 squared is 4. So now that we have this, we're going to write the left side as a perfect square, x minus 2 squared, and we're going to simplify the right side. Negative 3 plus 4 is 1. Tomorrow, we'll actually be solving for x.